Mihai Alden, and myself. And the URL development actually goes all the way back to 2009, and then it was open sourced in 2012. As you probably know, it's essentially two things. It's a data structure, and it's a toolbox of tools that you can use to do sparse simulations for things like water, fire, and smoke, and stuff like that. So next, please. So this is the technical steering committee, the current one. It has changed a little bit from last year. So we have Nick from Double Negative, Dan from Industrial Light and Magic. Peter, unfortunately, used to represent DreamWorks, but is currently on leave, and we're sort of trying to groom someone else to take over his spot. We have Jeff Lade from SideFX, and then I'm from NVIDIA, starting this year. So this is a list of the current third-party software packages that have adopted OpenVDB, and in the past actually the past half year, we had two new exciting companies. So we have Blender, and we have Embergen, a real-time fluid simulation that exports and imports OpenVDB. So that's quite exciting. Next, please. So a few weeks ago, we had the last major release. It was 7.1. It's a big release. There's a very long change list, but in terms of new features, it basically boils down to new tools that allow us to very efficiently compute distances. So we can use it to redistance distance fields. We can also use them to do something that we've never been able to do before, which is take attributes that are associated with a surface and then propagate it into the embedding space of the surface, which is very useful. This is a new algorithm that actually outperforms the existing functionality in OpenVDB. And there are, as you can see, there are actually 8 different tools that you can use. And they will, currently it's just a tool, but it will be exposed as Houdini SOPs in the future. Next, please. So one of the new exciting announcements we made this week was the intent to adopt what's called NanoVDB. So NanoVDB is sort of the first time that OpenVDB officially adds support for GPU acceleration. So next, please. It's contributed from NVIDIA, and it's characterized by two things. One is obviously the fact that it runs on the GPU. So OpenVDB, despite its success, has never actually been able to run on the GPU, both because of the algorithms themselves, but also because of the dependencies. So NanoVDB has very few dependencies. So in a nutshell, it's a serialized representation of the tree that is the backbone of a VDB grid. So it's pointerless, which means that we can copy it very efficiently from the GPU to the CPU. It offers the same benefits as we currently have in OpenVDB. In fact, a lot of our benchmarks have shown that it's faster than what we currently have in OpenVDB. It's initially sort of targeting real-time rendering applications. So unlike OpenVDB, it actually includes metadata that can benefit ray tracing and volume integration. So it has bounding box information baked into the data structure, and it also has statistics like min and max. You can do round trips, so you can serialize an OpenVDB to a NanoVDB, and you can go back again, you can do round trips. And it supports all the value types that you find in OpenVDB, including points. Another thing that is very unique is that it's agnostic and it's nimble, hence the name Nano. It's actually, the sort of core functionality is a single header file. So one of the complaints that we've had in the past when people try to adopt OpenVDB is there's a lot of dependencies. And some of them are quite tricky to build. And some of them you might not want in your project. So NanoVDB has none of those. The dependency on OpenVDB is completely optional. It's actually implemented in 2 languages, C++11 and C99. It also uses explicit memory alignment, which is new, and that actually allows it to sort of tap into a lot of different graphics APIs. So even though it's developed at NVIDIA, it's not biased against, let's say, CUDA and optics, but it also supports things like OpenGL and OpenCL, GLSL, and in the future we plan to add WebGL, Metal, Vulkan, and then it's also worth noting that it has a CPU fallback. So even though it's designed to run on a graphics card, you can also run it on the CPU, and the benchmarks that we've performed actually shows that it's slightly faster. Next, please. So another exciting addition to the library is AX. So AX comes from double negative. It's just-in-time compile expression language that's sort of specific to VDB. It was actually announced and released in a beta form at DigiPro 2 years ago. But now is the time when we believe that it will actually be ready for our production release, probably before the end of the year, or at least hopefully. So you're sort of seeing 3 screenshots. The 2 brown screenshots with code in it sort of illustrates the departure from sort of vanilla C++ code that you would need to write in order to have a procedure to modify the particle simulation that you see on the right. And at the very bottom, you see the same code written in AX. So it's very compact, it's very intuitive, and it's actually also very performant, which is really cool. So it actually targets the same speed as you would get with raw C++. Next, please. So this is sort of a dump of what we have on the roadmap right now. So as you can imagine, we are very busy integrating AX and NanoVDB. We expect it to come out hopefully before the end of the year. So we have 1 major release coming up soon. But we still have a lot of other things on the roadmap. So we still want to adopt true multi-resolution in VDB. So we're still collaborating with Autodesk and the Bifrost team that have a very cool approach to this. We are also talking to double negative, potentially to adopt distributed MPI support into VDB, and a ton of other tools that you can see on the slide. I won't go into all the details. Sort of in the more sort of what should I say? Things that you might feel on a day-to-day changes will be, we'll probably get rid of the GNU make system, build system. We want to rehaul all the documentation. We'll actually even rehaul some of the file structures. We also want to take another look at the math library. The unit tests needs to be beefed up, and some of the unit tests are actually too slow. So there's a lot of work in that space as well. But yeah, as you can see, there's a lot of work ahead of us. So if any of you are interested, we would love to accept you into the project. So next, please. So we have a website. There is a forum where you can ask questions. We also have a weekly meeting. It's Tuesday, 10 a.m. It's public, anyone can drop in. You can also find a link to the calendar. Sometimes we may actually end up canceling or changing the time, so keep an eye on that. But yeah, I hope to meet some of you online in the future. Thanks.
Great. Hi, I'm Doug Walker. I'm the technology lead for color science at Autodesk, and I'm serving as the chief architect on the OpenColorIO TSC. I'm going to give you a whirlwind update on the progress of OpenColorIO over the past year. Next slide, please. So OpenColorIO is an open source library for color management. It joined the ASWF in February of 2019 and reached adopted status in November of last year. It's developed at Sony Pictures ImageWorks, and it's supported in dozens of applications that are used in the VFX industry. Next slide, please. So the Technical Steering Committee provides the governance for the project, and we meet weekly at 12:30 Eastern Time. These are public meetings on Zoom, and anyone is welcome to join. The current leadership, which are elected roles on the TSC, Michael Dolan is from Epic Games is the chairperson. I'm serving as the chief architect, and Sean Cooper from DNEG is the representative to the ACES project. We welcomed 3 new members onto the TSC this year: Mei Chu from ImageWorks, Carol Payne from Netflix, and Mark Titchener from Foundry. Next slide, please. So this is a huge year for our project because we are launching our new version, OpenColorIO v2. So this has this initiative started in 2017 at SIGGRAPH with a proposal from Autodesk. We formed a OCIO v2 working group that year, and I'd like to thank the participants from the VFX studios and interested vendors for taking time to guide us on new feature development, review the code, etc. Their participation has been invaluable. And Autodesk stepped up and sponsored myself, Patrick Hodul, and Bernard Lefebvre to work full-time on this project. Patrick has been the lead developer for us. Next slide. So this is, as I said, it's 3 years in the making, and there are a ton of new features, and I don't have time to go into all of them. Some of the key ones are a new GPU renderer, native support for ACES, many user experience enhancements to make life easier for artists, new set of Python bindings that Michael contributed, and many other new features. Michael, Patrick, and I wrote a paper for DigitPro this year, and we went into more detail on all the new features, and we're planning on posting that on the OCIO website shortly. Next slide, please. So this is our timeline for the project. So for those of you who were with us at SIGGRAPH last year, in our roadmap presentation, we indicated that we would be feature complete with v2 at SIGGRAPH this year. I'm pleased to report that we've tracked that schedule well. We have a couple of pull requests landing last week and this week, but feature development is essentially finished. And we're now entering a 4-month period of stabilization and bug fixing. So this is the point in time where we are inviting developers to start integrating the new version into their applications and provide us feedback. We will use this 4-month period to do any fine-tuning of features and fix bugs and so forth. And then at the end of this year, we're planning on making the official stable v2 release, and that will be what products will start shipping with next year.
Oh, Lawrence, yeah.
OpenColorIO v2 is in the VFX reference platform for calendar year 2021. And so we're looking forward to seeing products ship next year with v2. Next slide, please. So I'd like to give a shout out to Mario Rokicki from DNEG for coming up with a cool new logo for the project and a visual identity guide. This is really exciting, and we are leveraging that for, and next slide, please. We are leveraging that for our refreshed website and documentation. So if you go to opencolorio.org, you'll see our new landing page, and this will direct you to our new documentation. The documentation is a work in progress, but we do have preliminary information on all of the new v2 features and guide to upgrading to v2. So we hope you'll check that out. That initiative was led by Carol Payne of Netflix and Sean Cooper at DNEG, and want to extend my sincere thanks to them for leading this initiative. Next slide. So we're looking for help and volunteers, first of all, to test the new version. We're also looking for people to write tutorials and review the documentation and let us know if there are things that they'd like to see added. There is a new version of the ACES config for OpenColorIO underway that will take advantage of the new features in the library to improve the accuracy, to improve the user experience for artists, and to make the config more compact. And so if you're interested in that, we encourage you to get involved. That group is meeting every other week on Tuesdays. We're looking for people to write new plugins using V2 and many more things. Just ask. Next slide. So here's how to get involved. The new code is available in the master branch on GitHub. The new website and documentation is at opencolorio.org. We have two mailing lists, OCIO-dev and OCIO-user. You can join these at the ASWF website. And we also have an active discussion on Slack. So you're welcome to join the Slack instance as well. So that's it. I hope you enjoy the new features in OpenColorIO v2. And that concludes the project update. Thanks.
Hi, everyone. I'm Brian Cipriano. I'm a senior software engineer at Google and the chairperson of the OpenCue TSC, and I'm giving an update on the OpenCue project. Next slide, please. Yeah, so OpenCue, if you're not familiar with it, is a fully featured render manager. We call it a render manager as a shorthand, but really any kind of distributed work can go through it. It's agnostic to the software that runs on it, so it can really run any kind of workloads you have. We joined the ASWF about a year and a half ago, just before last year's SIGGRAPH. So OpenCue was developed originally internally as a project at Sony Pictures ImageWorks, and we here at Google Cloud worked with SPI to open source it around January of last year. It's adopted by the ASWF shortly after that. And since then, we've built out a good pool of contributors and committers, especially on our TSC, from a bunch of different companies. All of the major cloud providers are included there as well. So we do regular releases, and we've done a bunch of work over the past year that I'll get into in a bit. Next slide, please. Yeah, so we've done a lot of work over the past year. We've done a lot of work on kind of sandbox deployments and documentation, help getting up and running OpenCue quickly. I think when we launched originally, it was quite complex to set up an OpenCue deployment, even just to try it out. So we specifically targeted that and have some good stuff linked on the OpenCue website for how to get an example deployment up and running quickly. We've, in working to expand our contributor pool, we've put together a bunch of contributor guides, guides for helping folks get set up on all the different platforms for making changes to the system. We just recently announced that our Windows support is moving to beta. I think at this time at SIGGRAPH last year, we had no Windows support. That was a few months ago. We released an alpha version of that. That's being now successfully used in production by a few folks. So we promoted that to beta status. So we're very happy to see that move along. We have also participated in Google's Summer Code program this year, which has been a really big success. We have been working on a cloud plugin for managing render nodes in the cloud via OpenCue, which should be coming out within the next, hopefully making its way into the main branch of OpenCue within the next month or so. We did a big migration to, along with the other ASWF projects, to migrate our CI pipelines and release pipelines into GitHub Actions. We recently completed that. So everything is kind of nicely natively integrated in GitHub now, and works quite well. Kind of the biggest piece of work we've done over the last year was all the kind of small improvements and bug fixes and stuff like that. I think that probably took the bulk of our time and a bit more than expected, but as a result, OpenCue is much more stable and nice to use than it was a year ago. So if you haven't checked it out in a while, it's definitely worth another look again, I think. All that is kind of wrapped up in the version 0.4.55, which just got released about a week ago. So that should be almost completely up to date with the master branch. So check that out. Next slide. Yeah, a bit of statistics on our on what we've been doing. So we brought the pool of contributors from about 6 a year ago to 24 now. Many of those are active regular contributors, which is very nice to see. The pool of committers went from 2 to 6 as well. We kind of have been very active in seeking out amongst our regular contributors folks who are ready to be reviewing code and merging it in, which is very nice to see. We merge about 3.5 PRs per week, which is about the same place we were about a year ago, but within a much bigger pool of contributors now. So it's nice to see things keeping pace there. And over the past year, we've closed 112 issues, which was great to see. Next. For the next year, some of these will look familiar from past presentations. Like I said, we spent a lot of time on kind of smaller changes over the past year. So now kind of turning our attention more towards the bigger ticket items. We definitely want to keep building out more Windows support. Things like, I think most of our documentation is still geared towards Linux users, getting started guides as well. We want to build out Windows versions of that much more now that we've entered beta phase and things are more stable there. User management permissions is a big ticket item right now. It's kind of things are fairly open within the system right now, and we're working on designing a kind of fine-grained permissions model for the system. Packaging installers is a big thing. Right now, there's a lot of, it's still a fairly technical task to set up and run OpenCue. Lots of command line to run, so we hope to kind of package that up and build some OS native packages, which will make things a lot easier. As we wrap up summer code, we're definitely going to be building more on the cloud support that we have. I think the kind of base layer of it is coming from our summer code student, and we definitely plan to build on that some more. We will definitely want to keep growing the contributor pool. I think we're very happy with what's happened in the past year, but we're always seeking out new folks to contribute and graduate to become committers as well. So always on the lookout for that. And we're also looking to get OpenCue graduated as a project within the ASWF. We're still currently in incubation status and hoping to graduate on that soon in the next few months. Next. Cool, so getting involved with OpenCue. OpenCue.io is a great place to start for users or developers. That'll get you started with documentation, installers, all that kind of stuff. Our main repo is linked here, where you can track our development status and file issues, all that good stuff. We have a users and developers lists and forums linked here as well. And we are also active on our Slack channel as well at slack.aswf.io on the OpenCue channel. So definitely find us there, where we're always hanging out and happy to answer any questions. And I think that's it for me.
Hello. I guess, go ahead, Emily. Thanks. So I'll give you a brief update on OpenEXR. And I think I see a bunch of questions in chat, so I think I'll kind of plow through a bunch of this stuff. So maybe go ahead, go next. And so I'll give a quick year in review, a little talk about ASUS, some of the stuff that we're doing for our next version of OpenEXR, and interesting development and split out of Imath. Next. So over the past years, we've released, I think, 8 versions of EXR. People quickly count. This actually represents more than had been done in the previous probably 10 years or so. And you'd think that's a lot of churn, but it's actually stability. What we did earlier this year is join up with the Google AutoFuzz project and have had them pounding away at OpenEXR feeding all kinds of garbage images to it. And so this is really about stability and making sure that it's a solid, secure library for being as foundational as it is. Next. Some of the other work that's been going on that we'll see happening is that during one of the quiet periods of OpenEXR, the ASUS container spec chose to use OpenEXR as the foundation of the storage format for ASUS, and they actually forked off sort of the definition of EXR. And they introduced a whole number of standard optional attributes, SOAs, and published a subset of OpenEXR as a container spec. This was never actually rolled back into OpenEXR, and so we'll be doing that over the next little while. And so if you could go next. And so this is a list. There we go. This is a list of those attributes, and the reason we're calling this out here is to, if you could look at this link at the bottom and take a look at these and see if you're using them internally, and see if the definition differs from what you have internally. Then I'm sure the ASUS container folks would really like to hear how they differ from what you're using. And so we can resolve any potential conflicts there. I think I'll leave I won't read them all out. And so next. There are a couple of new attributes in this. One is to remove some vague things such as aperture. So this is called out specifically as f-stop or t-stop, color temperature, firmware version, and as things have gotten more advanced and people are tracking temperature of lenses for correcting distortion, some other things just sort of became necessary. Next. And so on to the OpenEXR sort of major rewrite or not rewrite, major update for 3.0. We've done a couple of things. One is we're getting rid of the ILM IMF name in terms of the library and the folder, and it'll just be OpenEXR. This, if you're using the CMake layer, will be transparent to you because it'll just be the same CMake alias. The header file names are all staying the same. They're not changing, so you don't have to change your code in that. We've split out Imath, and I'll talk more about that in a moment, and sort of merging IEX and the ILM thread into OpenEXR, just because that's where its primary use was. And you can see the directory structure there. And part of this cleanup is we're actually we deprecated, and we're going to remove the auto tools and other similar things like that are sort of outdated. Next. Well, we're at that sort of giant reorg. We also are going to get rid of the master branch and have a dev and a release branch in the name of more inclusive language. But it also is clearer just to know, where development is happening, and what a stable release branch is that you can pull on. So next. So as I mentioned, Imath, we've pulled that out. It's a separate repository in 3.0, and it's largely going to be header only, and it's the subset that people found useful to integrate elsewhere, such as I think Larry uses it in open shading language a bit and things like that. So maybe OpenVDB as well uses it. Next. And so one of the things that we've had a Google Summer of Code student, Owen, working on this as his primary task. And so part of what he's done is modernize the library a bit, keeping a simple API. There's more inline headers. We've removed the IEX and have, it's clear when you have a function that can throw an exception when you have one that doesn't throw exceptions. He's done a lot of work with making things const expr such that they can be more closely optimized. And finally, the library is CUDA compatible with the half type in CUDA. And so you can actually use Imath both in host code and in CUDA kernels, which is pretty neat. Next. So back to OpenEXR, we are still looking at a couple of things that actually cause the file format to change slightly. We're still examining whether to add the bfloat16 support as a supported data type. We're also looking at sort of compressing and making some of the parsing of OpenEXR files a little bit more efficient. And one of those methods might be to move required attributes up to being a little structure at the beginning of the file. And another method might be to actually move large chunks of metadata into their own part type. Next. The other thing that we're doing in OpenEXR3 is making a new core I/O layer. This is largely driven out of a need for more performance. The existing library has some good threading support, but it also has a fair amount of overhead associated with that. We're rewriting the core of OpenEXR to have a low-level C API, which will be fairly minimal but complete, and then rebuilding the C++ on top of that, and it gives us a good way of making sure that we're retaining exactly the same API and the same behavior. But it should be, this also enables us to add new, more thread-friendly API, such that you can have 48 threads or however many threads you have in your machine blasting away at the same EXR file. Next. And so just a quick preview of that. This is on my little machine at home. This is a ratio of the old library to the new core in terms of reading an image sequence. And so it's a percentage of, or a ratio of improvement. So you can see that even up into hyper-threading, there's still some performance gains to be had from just the better management of threads and lower I/O. Next. And so again, thank you to Owen, who's spent the summer with us and has really helped clean up the repository quite a bit and modernized it. And if you go on to the next slide, Emily, it's the last one. It's just how to get involved. And it's the usual list of things: the email list, the email archive, our repository. We meet every other week. For me, it's Friday, but I think for those in America, it's on Thursday afternoon. And so hope to see you guys there. Thanks.
Hello, I'm Nick Porcino. I'm representing the TSC for OpenTimelineIO. Next slide, please. So OpenTimelineIO is a project developed by Pixar Animation Studios. We joined the ASWF last summer, and so we're pretty new. It's an open source interchange format for editorial timeline information. So the kind of information that you're going to read and write out of like Avid or Adobe Premiere, things like that. It's a collection of adapters for common file formats that are used throughout the industry, all the way back to EDLs. And we also have a set of libraries that you can use to develop new functionality and directly integrate OpenTimelineIO. we have a very active community that we're very grateful for. And today we're releasing Public Beta 13, has a number of interesting new features in it, and I direct you to the release notes. Next slide, please. So the motivation for having something like OpenTimelineIO is that over time, huge numbers of editorial decisions accumulate into a project. It can represent thousands of clips and dozens, if not hundreds of tracks. And on the little small screenshot that we've got here is a portion of a recent film, like just kind of zoomed in to give you an idea of what the complexity of a timeline like this is. There's years of decisions in there, and being able to take that information consistently and losslessly between the various tools in the editorial pipeline is really crucial for maintaining like the coherency of the timeline and creative decisions across the workflow. Next slide, please. So an OpenTimelineIO file itself is a collection of tracks. The tracks have clips. The clips reference media that can be in any kind of format. And the clips are composed onto a track via like gaps and transitions and are annotated with markers. And this is all done in a consistent and coherent way. Next slide, please. So the way that you interoperate with OpenTimelineIO presently is via the OpenTimelineIO convert tool, which is a command line tool, takes OpenTimelineIO files and converts it to and from EDLs, ALEs, Final Cut XMLs, Avid AFF files, and so on. And you can extend the system yourself by writing your own plugins for your own formats in Python. Next slide, please. So the, let's see, this slide is the native C++ integration. Native C++ integration lets you read and write and operate with the OpenTimelineIO data structures in memory in your application directly. This kind of integration is much more seamless than going through file adapters and pipeline file-based workflows. So we're hoping that we're going to see a migration over the next little while to native integration of this nature. Next slide, please. So in addition to the bindings and the conversions and the file format, we've also got a timeline viewer. And this is just a little screenshot of OpenTimelineIO view showing how you can inspect a clip and look at a bunch of metadata. This is super helpful for understanding how data is transformed as it moves through your pipeline and just inspecting things for basic workflow and debugging operations. Next slide, please. So today, this is our battle-tested workflow. The hat with the ears is our proprietary Presto animation system. So Presto reads and writes OpenTimelineIO. OpenTimelineIO converts to AAF. It heads over to the Avid and for editorial decisions and editing, and finally comes all the way back to Presto. And on the way, it can be sent out to RV for viewing or for archive. And we can also send EDLs over to grading. This is the historic workflow. Next slide, please. Yes. Oops, one back, please. So as we move forward with integration, things should be much smoother and much more streamlined, where OpenTimelineIO files are first-class citizens throughout the entire pipeline. Next slide, please. The original release of OpenTimelineIO last year was implemented in Python, and it included OpenTimelineIO convert. Next slide, please. Earlier this year, we released a version where we built a C++ core API, rebuilt the Python API on top of that, and the rest of the pipeline remained the same. Next slide, please. This year, as a result of having the C++ integration, we've been able also, thanks in large part to Karthik Ryder, our Google Summer of Code student, we've been able to introduce new bindings, particularly for C and Java, which really broadens the places that OpenTimelineIO can be natively integrated. Next slide, please. Another contribution, this one is a community contribution that we're very grateful for, is the ability to ingest image sequences directly. So previously with OpenTimelineIO, when you had a directory full of images that might have come from a rendering application, they were they would have been in the form of a big pile of loose files, and you would have had to reference them individually into clips. The contribution here was to describe what the naming convention is for files in a directory, and then make image sequences within your tracks that can automatically discover the files and incorporate them into the timeline without that time-consuming extra step of needing to make clips. Next slide, please. So this is just a quick summary of updates on our adapters and improved file format support. There's the AF adapter for Media Composer, and the Final Cut adapter has learned all about complex nesting and varied frame rates. Our EDL support now supports wipes, reverses, markers, and a lot of other interesting new things. And you can see a couple of other new excuse me, a couple of other plugins that have just recently been introduced. Next slide, please. So another development that we're excited about is integration with RV. So previously, OTIO Convert could create RV files, and then RV could open up a playlist for preview or review. Next slide, please. Now there's a native plugin. So RV can read OpenTimelineIO files directly, which is a great workflow improvement. We can't write playlists from RV. So if anybody's looking for a place where we would love to have a contribution, being able to export a playlist from RV out to OpenTimelineIO would be fantastic. Next slide, please. So here's a screenshot in RV showing a little bit of that really complicated timeline from the earlier slide, just playing back natively in RV. So this is very exciting. Next slide, please. So how to get involved. We have a number of community projects underway right now. And well, obviously I'm very excited about this. So anyway, we've got effort to improve continuous integration and how our build systems work. There's language bindings underway. We've got an effort to fully specify what the OpenTimelineIO file format looks like and what it contains and what the expected operations on OpenTimelineIO are. There's work on coordinate systems, both temporal and spatial, and the hierarchies thereupon. And this is important so that we can start to encode information in timelines, like the position of a clip region, for example, over time. And there's work underway to design an editing API. And this will have common operations in it, like splitting and merging clips, calculating intersections between elements, and so on and so forth. There's Blender integration underway that will provide interoperation with Blender's fantastic sequencing tool that they've introduced in the last release. And we're also starting to carry lens metadata, which is really quite an important thing, because if something comes along, some media source, and it's referenced into the timeline and it goes through a number of transformations along the way, and in some cases, we're going to want to be able to recover data, like the stuff that Kimball was mentioning earlier with the ACES effort. We might like to keep that information throughout the pipeline, recover it later, and then potentially put it back into the files where it needs to be. So this provides a way that the lens metadata can actually survive transformations through the entire editorial pipeline. Next slide, please. So how to get in touch with us. I've got the URL there for our landing page, and the landing page has links to our Slack channel, our GitHub, our Read the Docs information, our mailing list, and every 2 weeks we have a meeting, and you can find it on the ASWF calendar, and we invite you to join us. So thank you very much.
Hi. Hello, am I on? Very good. I'm going to give an update on Open Shading Language. Next slide, please. Next. Just to review, shading is the part of 3D rendering that makes objects look like different materials, like wood, rusty metal, concrete, or cloth. At each point on the object, what color is it? How bright is it? How much light reflects to which directions? Next slide, please. So Open Shading Language is a domain-specific language that is used as an extension language for renderers to let people describe patterns and materials. This software is delivered in the form of a library that's embedded into renderers. So it's not really a user level app, but it goes inside other apps and renderers. This was a project that was started in 2008 at Sony Pictures ImageWorks for use on our proprietary renderer, but fairly early in its life, we decided to open source it under a fairly permissive BSD license. And since then, it has been adopted into many other renderers, both open source, commercial, and proprietary across the industry, and has had over 50 contributors to the code itself from across the industry. Its rapid adoption in so many products and to become the de facto standard earned it an Academy Science and Technology Award in 2017. And earlier this year, we submitted the project and were adopted into the ASWF. Next slide, please. Next. So there have been other shading languages before, but some of the design goals that really make OSL a little bit different are that we really designed it to be used in modern physically based path tracers, which is the direction that the industry is clearly going. And at the core of it is a lot of new compiler tech. So we can be very efficient by doing a lot of very aggressive optimization and compilation down to machine code on the fly in the middle of the rendering process. We worked very hard to make sure that the language was not tied to any specific piece of hardware, and also not tied to any particular rendering algorithm, and certainly not to any product. And because of that, and its Roshan as an open source project, really, this is probably the only shading language implementation that's been used, in many different products from different companies and with different rendering algorithms underlying them. Next slide, please. Next. We know at least 120 movies depend on open shading language for their shading, and that's probably a vast undercount because at this point, nearly all of the high-end rendering systems used for film support OSL to varying degrees. So it's actually quite challenging to try to keep track of all the projects that use it. Next slide, please. Thanks. Yeah, great. Update on important things that have happened to us in the last year. As I said, we were adopted as an ASWF project. So rather than being a bit of an ad hoc run project primarily from one company, now we have a formal charter and governance rules for the project, and a technical steering committee that is comprised of representatives from many of the major stakeholders, including Sony, Animal Logic, NVIDIA, Pixar, DNEG, Autodesk, Leica, the Blender project, and there are many other participants as well. We have a new set of mail lists, so if you found yourself on the old mail list, just go to the ASWF page and sign up for the new one. That's where all the exciting conversations are happening. We are in the midst of signing new contributor license agreements. Again, if you sign the old ones as a contributor, you will need to do the new ones, but they're very closely related. It's only a minor change from the ones we had in place before, so hopefully this will be straightforward for you. And once that's done, we will formally move the repository for the code from the ImageWorks GitHub page onto the Academy Software Foundation account. And one of our big goals, like when we submitted the project, like the major part of the motivation there was to take this project that is important industry-wide infrastructure and really emphasize that it needs to be a community project. There are many stakeholders, and we don't want it to be perceived as owned by a particular company. It's too important for that. So part of our goal here for graduation from an incubating project to a fully admitted one is committed diversity. And we don't mean that in the demographic sense. We mean making sure that the people steering it and the people writing the code and committing the code and the ideas are really not bottlenecked on any small number of people or companies, but is broadly representative of the major stakeholding companies and projects. Next, please. Nice. We also are in the middle of a major release right now. We entered beta at the beginning of August. We hope to have a final release on September 1st, which will make this the new supported production release family. We have some language improvements for shader writers. We've updated some of the major dependencies. In particular, we've dropped support for some of the older LLVM versions and added for some of the newer ones. For renderers incorporating it, we took some care to make sure that we now support thread-safe parallel shader setup on the renderer side. And we've also improved some of the just-in-time compilation speed. Right, so test if you haven't already. We would like to obsolete the older 1.10 release and make this the supported one moving forward in fairly short order. Next slide, please. Great. So there are many things that we can and will do in the future. Right now, there are two big development efforts underway that I want you to be appraised of. The first one is there's an effort that is led by Intel and Pixar to add a new interface for renderers onto OSL that allows you to shade not just one point at a time as we currently do, but to shade in batches of 8 or 16 points at once, with batches of points with needing the same material shader to be run. And the point here is to take advantage of widely available hardware, in particular Intel's AVX and AVX 512 instruction sets that can operate in a parallel manner on sets of 8 or 16 floats at a time. And so we're reducing the cost of evaluating many points at once. The work is mostly done, and it's already being used in production and in the RenderMan product at Pixar. And we are breaking it into chunks to integrate back into the main branch of OSL development. So we're in the midst of that now. The other major project that's going forward, which has had a lot of work initially by NVIDIA and is now getting work from others, is to make a GPU backend for OSL, particularly targeting CUDA and optics, which seems to be the direction that most of the high-end film renderers are going for their GPU support. And we already have the basics working for many shaders, but there are many corners of the language that have not been fully fleshed out on the GPU side. So this is ongoing work, but a future major release, we hope we'll be able to say that we really do support like all reasonable things you can do in the language. Next slide, please. Great. So, if this interests you, the obvious ways to follow along are to watch the issues and pull requests on our GitHub page, subscribe to the ASWF mail list where the development discussions happen. And we, like I said, we do have this formal technical steering committee. The meetings are open and they happen every second week on Thursdays at 2 Pacific time as a Zoom call. Those are public. Just look on the ASWF meeting calendar and drop in if you're interested in seeing how the sausage is made, so to speak. Next slide, please. Great, and that's all I have for you, so thanks for your attention.
So now we can open it up if there are any Q&As. I did see that there was one, I think this one's for you, Larry, about our existing CLAs invalidated with the new repo.
Yes, the old CLAs for the old commits are fine. You don't have to re-sign CLAs for the things you did before. But even if you signed one of the old ones, that basically covered contributions to the ImageWorks owned repository. So when we move the repository over to the ASWF account, you will need to have your company sign the new CLA for the new repository. This is true of all of these projects. It's not specific to OSL.
Any other questions? Okay. Well, in addition, we will be trying to post this probably later next week on YouTube. And for those who missed our open source days, which was last week, all of our projects did give in-depth talks. And those will be posted on the Academy Software Foundation YouTube channel later this week as well. I encourage you to join our Slack channel. And then if you want to figure out also how to get involved with all the different projects on the ASWF site, aswf.io/projects, and I'll post it in the chat. There's all the different channels for all the projects. So great. So thank you everybody for joining.